We're good. All right. Good afternoon, everybody. Hopefully you're here and excited to learn about automating storage migrations. I am Dave Stauffacher, Chief Platform Engineer at Direct Supply. We're based up in Milwaukee, and we are a company that focuses on products and services for the long-term care industry. So think like assisted living facilities, nursing homes, things like that. I've been with the company just shy of 22 years. And for about the last 20 years or so, I have specialized in data storage and data protection. So between 2003 and 2019, when we made our big cutover into the cloud, our storage platform grew by 30,000%. So I was certainly given a lot of opportunities to learn and trial by fire to learn how to manage storage. So 2016, we were facing a looming crisis on the horizon, needing to renew a lease in a colo facility, lifecycle our entire SAN and NAS infrastructures, as well as overhaul a number of other systems in our data center. They all kind of converged at the same time. And that made the economics of cloud very attractive to our financial people. So in mid-2016, a small group of us started experimenting in cloud. And in 2017, we formed our first cloud engineering team and started rolling forward with migrating in the cloud. Now, fun fact, this is my third time presenting at Midwest Community Day, actually fourth time now because I was just pulled into something. But this will be my fourth time presenting at this conference. And I mentioned I'm an AWS Hero nominated by the storage teams. And all of that happened because of my first talk at this conference. So if AWS Hero is something you're interested in learning more about or getting more involved with the AWS community, feel free to come see me afterwards. I love talking about this stuff and how this platform here, this conference can be a real springboard for your career. All right, so background. Today we're going to talk about our corporate monolith file server. This thing has been around longer than I have. It is old enough to vote. It is old enough to drink, and it's probably old enough to rent a car without paying extra penalties. It is massive. And so in 2019, we had to get it out of our data center and into the cloud. So the picture you see here is actually my teammate, Jack, with our entire file system on an AWS Snowball, pedaling it with one of our delivery carts, getting it over to send all of our data back to Amazon to start seeding it in the cloud. I've been working with Amazon on the FSx platform, both as a beta tester and on their advisory board since early 2018. And so we knew where the platform was going, and we knew it wasn't going to be ready when we needed it in 2019. So we picked a different cloud platform. It was a third-party thing that we could run in AWS to be our file system of choice for the first few years. And then when FSx was ready for prime time, we started the project to migrate over to it. So this file system, when we moved it out in 2019 on the Snowball there, it was 9.5 terabytes, maybe 10 terabytes. It's now 20. And so we had to move more than double the data we did in our first shot out to the cloud. Also, fun part of the migration is that there's a small subset of the data that's made up of over 1 billion, 1 kilobyte or smaller text files spread across 350 million directories. And so moving that proved to be its own set of challenges as part of this migration. And we'll talk a little more about that in a minute. All right, so we went into this very optimistic, and our plan was we'd deploy FSx. We would use AWS Data Sync to synchronize the data from our old file system onto FSx. Once all the data was copied, we would take a maintenance window, fail over, everything would be great. We thought it'd take a few weeks, maybe a month to get this done. And then we'd have a big party to celebrate. It took us about a year, and we'll get into a little bit of that in a second too. The approach I wanted to take, though, is something that I learned from watching the last space shuttle launch. So anyone here ever seen the space shuttle launch like on NASA TV? You ever watch their process? NASA is like the master of choreographing run books across multiple teams. And where they have hundreds and hundreds of people with like to the second precision on their tasks. I had like 3, but I needed that same level of precision. So I took some guidance from how they structure their launches to build out a run book, and then realized that where I only have 3 people, we had to substitute automation for warm bodies to help with the cutover. Okay, so we started the automation process by using Terraform to deploy our file system. Everything we do at Direct Supply in the cloud, if it can be terraformed, it should be terraformed. So FSX was no different. And we knew that in addition to this monolith, we had a few other file systems that we're going to need to move out there. So instead of just building a one-off set of code, we built a module, a Terraform module that would allow us to build multiple file systems using the same underlying code. So if you look at the code here on the left, that's really all we have to pass in to the module to get an entire file system stood up, joined to the domain, have everything provisioned exactly the way we want it. So that includes, you can't really see the arrows there, but so availability zones, we were using 2 of them because we wanted the high availability FSX design. And then it auto joins our Active Directory. It creates and populates our admin groups, enrolls it in AWS backup, and sets up all of the DNS and routing that we're going to need to do to make this file system become the monolith. And then we can repeat this and reuse this for every other file system that we move out there. So we've got 5 more that we've already done. We've got a handful from on-prem that are going to follow the same pattern using the same module as well. So that was our first step. The second step was we had to automate data sync. Is anyone here familiar with data sync? Have you worked with data sync? Okay, a few of you. All right. So data sync has a few different components to it. You have a source location and a destination location, and you set some copy parameters in there to create a data sync task. Then you create a data sync agent or a group of agents, and that's really the compute behind your copy task. So in this case, our source location was our old cloud file system. Our destination was FSX. And then we started off with a 1-to-1 ratio of, or a many-to-one kind of architecture of many tasks to one agent. And then we had some areas where that worked. We had some areas where we ended up with many agents for one task. But in the end, when we automated the data sync stand-up, we also created all of the tasks that we needed to roll back if something happened. So going into the night of the migration, we were all set with all of our data sync was running from the old location to the new. But if something went wrong, we had to be able to get from the new back to the old. So we let the Terraform automation take care of that for us. Now, I'll say this too, we started hoping that we could get this entire thing copied with like 8 or 10 data sync tasks. In the end, to hit our performance needs and to get our maintenance window as small as possible, we ended up carving things up into 150 different data sync tasks for the rollout and 150 for rollback. So it got very big, but it scaled very quickly and easily. The Terraform is largely copy paste, and we could deploy the entire environment very, very rapidly. We also found that by scaling it up as much as we did and scaling it out as much as we did, that we were able to drastically improve our parallelization of the copy tasks. And that helped us get a much faster migration as well. Okay, so I'm going to break the migration down into 3 phases. We have the migration prep, we have the actual migration itself, and then we have the rollback information or the rollback automations on the off chance that we needed them. So some of the tools that I built, and all of this is open source. I'll give you a link to it at the end of the talk. So if you want any of my tools, you're welcome to them. I drove everything off of groups of data sync tasks. But in order to figure out what tasks I could run at the same time or kick off at the same time to really maximize efficiency, I had to build a task that I called the get runtime. This goes out and checks all of my tasks, all 150 of them, and tells me how long they're taking to run and how frequently they're running. So we can look at that data and figure out, okay, these 5 tasks can all finish within an hour. So we could run those all together and then stuff some more in there alongside of them. And then we needed a way to check to make sure all these tasks that we're running are healthy. So there's a get status task that I wrote, and that goes out based on these groupings of data sync tasks. And it'll tell you how long did the last task take to run and was it successful or not. So that way, leading up to our migration, we knew where our pain points were and we fixed any like data integrity issues that might be there. How many tasks was something I wrote to please my boss. He kept stopping by and asking how many tasks and how many agents we were using. So that's just a quick little script to give him an opportunity to answer his own questions without bugging me. And then the last thing we needed before the migration started was I needed to eliminate all of the schedules from all those 150 tasks, because I wanted to make sure that once we took our maintenance window and started, took the file system offline, we had 100% control over what was running, in what order, and when it was going to run. So eliminating all of those task schedules was critical to that level of control we needed. Now, this task, and you'll see it in the repo here that I've shared, this task also backs up those schedules. So if something goes wrong, we can restore those schedules easily and get the data back up and synchronizing, like if we had to set up for a second attempt at the cutover. Okay, now for the night of the migration, about 2 hours before we started, we ran a script that I wrote to stop all of the tasks. We didn't want anything running outside of our control. So anything that was running, we killed off. And if this is something you're looking at doing yourself, one of the gotchas is that you have to kill off the in-queue tasks or the pending tasks first before the running tasks. Otherwise, you're just going to perpetually play whack-a-mole with the next round of tasks starting and starting and starting. DataSync has an option to preserve deleted files. So if I have data at my source, I copy it to my destination, and then I delete it at the source. Well, I don't want that hanging around my destination as long as we haven't officially cut over yet. But we knew that some data was going to have to trickle in after we went live on FSX. So we had to manipulate those tasks so that if there was something at the destination that didn't exist at the source, it didn't blow that away at the destination. All right, then we get down to the nitty-gritty of starting the tasks. And like I said, we had groups of tasks and we had a very set schedule. And this is where we get to that NASA level of precision. We knew how long each task was going to take. So we could say, okay, this group of 5 tasks is going to take exactly 45 minutes to run. And we could start that and then say, okay, and I could start the second group without any impact or, collisions. And that's going to take an hour to run. So then I could go forward in my calendar and say, okay, now I need to validate those tasks. So we run a command, we start the tasks, and then we run a command when we know that job should be finished to validate those tasks. And this is what the output from that looks like. So it tells you the task, make sure it was successful. And it gives you the start time, which is really important because if not all the tasks had kicked off yet, the start time would still show like yesterday's date. So it's important to make sure they all started within the window that we thought they started. Now, if I were going to build this out more and make this, a full-time gig maintaining this code, I'm sure that the start tasks by group could be tied into EventBridge somehow, and you could trigger alerts that would then kick off a validate task Lambda that would then give you the information you want. I just didn't have the time to cable all that up. All right, now, if things went bad and we had to roll back, we needed some tools that would, again, stop all the tasks. And then because our data sync module created rollback tasks, we had scripts that were able to identify those rollback tasks and run them in the same order that we ran our rollout. See, the thing is, we have some really mission critical data on this file system, and that had to be copied while we were offline. The rest of the stuff, like Office documents and pictures of random campus events, those could flow in after we're already live on the new file system. Anything that changed in the last 24, 48 hours, no big deal if that takes a few hours to synchronize. But for the stuff that we need to move during that outage, we needed to have the same level of control over those tasks so that we could get as efficient a rollback as possible. And again, we had to validate those. So it's pretty much the same tooling for the rollout, just updated to manage the rollback tasks. After the rollback would be done, we're going to need to restore those task schedules. So we deleted them earlier. That outputs a CSV. This task will pick up that CSV and roll those schedules right back out to all the tasks. So once your rollback is complete, you can get back to the business of setting up for your next attempt at the migration. And again, just the opposite of the deleted file script from the night of migration. We'd want to put that back if we were going to have to roll back and take a second shot. So all this worked really, really well. We were able to successfully migrate. We expected about 16 hours to migrate, and we were done in less than 12. So the fate smiled upon us for this migration, and all the automation running and all the tooling that we built meant that with just 2 engineers and 1 member of SRE, we were able to get the rollout done. And then our test engineers were there to validate after we rolled out. All right, so a few lessons that I learned from this process. Number 1, know your data. So if you don't know that you've got 1 billion 1K files, one data sync task is not going to cut it to move that data. So you have to understand where you're likely find your pain points and make sure you're architecting data sync to address and account for those. And then with the automation, it doesn't matter if it's 1 task or 20 tasks, you can make a very easy pattern for rolling those out and getting those run on your schedule. Number 2, don't be cheap. So our migration to FSX was strategic. We knew we were doing it, but it also came with a big cost savings. So moving to FSX, we saved about $300,000 a year in hosting this data. So we wanted to make sure that we weren't going to spend a ton on the migration and undermine the savings we were hoping to get. And so I made the mistake of undersizing the throughput on the file system and oversubscribing our bandwidth in the tasks. And that was leading to tasks taking days to run when they should have taken minutes or tens of minutes to run. So scaling up the throughput on your file system is critical to doing anything with data sync. And then just making sure that your tasks are getting enough resources with their agents and making sure that you have the right size agents to be able to move your data correctly. The other thing on scaling up throughput is, and they tell you this in the console if you do things through the console, but you never see the errors if you do it through Terraform. When you go to expand an FSX file system, if your throughput setting is anything less than the max 2 gigabytes per second of throughput, that operation to grow your file system can take weeks to balance out and level out in the end. And that means you can't do anything else to your file system, like change the performance dynamics or grow it again. If it's rapidly filling up, you're stuck waiting for your file system to level out and rebalance. So scale up your throughput before you do anything to your file system. That's critical. Even if you're after a migration and you want to add 5 terabytes to your file system, bump your throughput to the max, and then your grow finishes in like 45 minutes. So very critical lesson. All right, next thing we learned, SMB session caching. We were a little bit naive and thought that if we took down the DNS entry that had a time to live of 1 minute and killed that off, the things that we're talking to it would suddenly lose their connection and sit there waiting, retrying the DNS entry for the new A record that was going to replace it. That didn't happen, and some servers just kept their connection. So we found after the migration, we had a bunch of servers we had to reboot. So my next recommendation here is just shut down any hosts that are going to be talking to this data to make sure they're not changing your data unknowingly. It'll make your headaches a lot fewer when you come up on the new file system. All right, seed your rollback was another good lesson we learned. The first copy that data sync, or first time data sync runs a task, it's a full copy of your data. So if you don't take a bit of time and seed that rollback to at least have the full out of the way, you cannot get away with running an incremental to move just change data back. So if I had to do this big migration all over again, I would have paused and run my rollback scripts and my rollback commands and tasks before the night of the migration, so I at least had a foothold on a rollback, so it was incremental instead of full. especially when you're dealing with 20 terabytes, that can take days to roll back. All right, and then the last thing that I learned is more about code structure here. But we had one repo that included our calls to the FSX module and our calls to the data sync module. Now, the data sync module is creating that task that has a source and a destination, and there's also some logging thrown in there and some security groups thrown in there. So for every one task we created, we had 5 objects that Terraform had to tear down. So at 300 tasks, that's 1,500 objects that are getting destroyed. And then you also got the agents and their security groups and their policies that get attached to give them access to the data. So you end up with thousands of objects in Terraform that are getting torn down when you just try to get rid of the data sync tasks. We had so much in our output because there were so many tasks that I actually wrote a parser to go through that Terraform output and highlight anything that was being destroyed so that we could just scan through that list quickly without reading all of the extra details Terraform provides. Because the last thing we wanted to do is accidentally tear down something that is needed for our file system when we're just trying to clean up the data sync tasks. All right, so there are links to all of the code that I used for this migration. If you hit the QR code here, that'll take you to a list of all my links, and you can get all the scripts right out of that repo, and feel free to do with them as you need to. Otherwise, if you have any questions, I'd love to take your questions. Yeah. So I would chalk that up more to tribal knowledge than running a formal classification project. Ultimately, we agreed as an organization that this would be the last time we rehome this file system as one giant monolith. And we probably wouldn't have done the move to FSX when we did if there wasn't a nice juicy cost savings out there. We wanted to save that money so that we could reallocate it towards resources to actually focus on splitting this file system up into individual buckets of data on their own discrete file systems that are managed by the appropriate teams. Like right now we have, order processing data sitting on the same disk as, pictures of a company picnic, right? And so when we're dealing with AWS backup and the way you restore FSX, you restore all of it to restore some of it, right? We turn on VSS backup so we can get some individual file level stuff. But in a disaster, right, we're going to be handcuffed to restoring all of our data versus just little bits of it. So we moved it with that being the concession we made for now, knowing that our next step is we're going to get away from that monolith restore going forward. Any other questions? Yeah. Yeah, no, there is no DFS in play right now. When this file system was born, DFS wasn't really a thing. And we have the namespace is critical in the org, right? Like everything knows to write to whack file server name. Whether that's an application, whether that's an end user, logging scripts on a laptop, all of that writes there. And by the time that DFS was ready for prime time, any movement into DFS to try and make this easier would change. You'd have to have it in Active Directory for high availability. And then it becomes file server dot domain name dot everything. And you have to use that FQDN. And because there was a lot of data and a lot of process that existed before that was the standard, shoehorning that in would have been, I mean, we have 25,000 code references hitting this file system day in and day out. So it would have been a massive undertaking to just, Control F, Control H, you know, that would have been ugly and break a lot of stuff. So we've looked at other ways to do that. There were some third-party products that you could slide in without breaking the namespace, but before we could even get a purchase order together, those products were off the market and deep sixed. So I don't think we'll pursue DFS going forward either. As we break this up, we'll break things up into smaller, more application-focused file systems where the high availability of FSX will be adequate for what we need, and we're not going to need to ship a namespace around the world. Yeah. 100% of what we deploy in the cloud is Terraform. So, and anything we're going to do more than once, we try to build modules for and try to make sure that we've got highly reusable code. So we had, in this case, the Terraform was for all of the tasks, all of the agents, the location, source, and destination, the rollback tasks, all of it was 100% Terraform. Yes. Yeah. Yep. Go for it. We will likely not pursue FSXN. It's just not a good fit for all the tooling that's already running in our environment. But that said, not all of this data will continue to live in a Windows file system world. There is a ton of this data that would live perfectly fine in S3 and actually give us new capabilities if we were to, make that S3 part of a lake that we could then, run queries against and survey the data differently. So, yeah, and probably some of this data is going to go into like Office 365 or other managed services. The goal is I don't want to have to manage any more platforms than I absolutely have to. I hate patching. I hate midnight maintenance windows. So if we can get that farmed out to managed services or get it to places that just don't have patching cycles, that would be much better. And S3 is going to handle 1 billion 1K files way better than a Windows file system is going to handle it. So, yeah. Got any more? Yeah. Not yet. So everything that's hitting this, or almost everything that hits this file system, is in cloud already. We have some applications that were highly sensitive to latency, especially like application to file system stuff, and then application to end user compute. So we actually run about half of our company out of Amazon workspaces. So our latencies are really nice and low. Everything's running happy. I have some other data sets that live on-prem still that are tied to incredibly latency sensitive applications like, AutoCAD, some 3D rendering stuff, all of our creative teams that handle all the artwork for a 2,000-page printed catalog. All that data needs to sit as local as possible to the end users. So our plan is that after we get through a few more projects that we have in the pipeline, those gateways are coming in, and the gateways will then act as the on-prem local presence for that data that'll then be mastered in AWS. The data is already data synced. It's already copied out there and ready to go. So if something happened to our on-prem data center, we could update DNS and say, you may have lost some data, but here it is. Enjoy the latency while we get this fixed out. But that said, I've also beta tested the appliances. If you look on the AWS storage blog, I have a post that goes into detail about all the performance testing I did, like beating them up and comparing their appliances to our on-prem NAS and looking at what those performance variances look like. And I can't wait to get those gateways in. Way more cost effective than a NAS lifecycle. Yeah. Any other questions? Cool. All right. Well, if you have anything more you want to follow up with me on, all my socials are under here, my email address, all the code for the talk. If you want to learn more about AWS Heroes, I'd love to talk more about that too, and AWS community stuff. So thank you all for coming, and please come find me later if you want to chat more.